Bismillahirrahmanirrahim. We are discussing second year mathematics. In this video, we will start our next chapter. We have discussed 5 chapters of second year mathematics. Today, we will start the 6th chapter, integration. So, in this chapter, we will learn everything about integration. So, there is a little introduction of integration. So, we have studies in the previous unit 4 and 5 about the derivative of the function and various applications of derivatives. A material that belongs to the branch of the calculus is called differential calculus. In this unit we will study another branch of calculus which is called integral calculus. Like the derivative of function, the definite integral of the function is special limit with many diverse applications. Geometrically, the derivative is related to the slope of the tangent line to the curve, while the reverse of derivative is the definite integral, which is related to a area under the curve. So we have a function f of x. When we want the slope of the tangent to this function, we take the derivative of the function. So when we have the derivative of the function, so we want to find the function from this derivative, then we take integral of this derivative and we will get the original function. Next, he is discussing some more things about derivative. So, functions which are used in the applications in previous unit have provided information about a total amount of the quantity such as cost, revenue, profit, temperature, gallons of oil, or distance. Derivatives of these functions provided information about the rate of change of these functions and allow us to answer important questions about the extrema of the functions. It is not always possible to find ready-made functions that provide information about the total amount of the quantity, but it is often possible to collect enough data to come up with a function that gives the rate of change of the quantity. A cumulative point of the view is that the derivative gives the rate of change when the total amount is known. The reverse process of derivative gives the total amount of the quantity when the rate of change of the quantity is known. The reverse process of derivative or anti-derivative or anti-differentiation, inverse process of differentiation is main topic of this unit. So when we have a function f of x, and when we want to find the rate of change of f of x, when we want to find the rate of the change of f of x, we find the derivative. We find the derivative of f of x, which is f prime of x. When the rate of change of the function f prime of x is given and we want to find the original function, for this process we take the integral. We take the integral of the function. Let's suppose we have a function f of x. So when we take derivative, it will give us a rate of change of the function. And when we take the integral of the function, integral of rate of change, we will get the original function. So integration is as in inverse process of differentiation. If f of x is any unknown function and its derivative is f prime of x is equal to f of x, say then the reverse process is to give a function f of x such that its derivative is f prime of x is equal to f of x. F prime of x is equal to this one. A function f of x is called antiderivative of the function f of x or interval on the interval ab if all the points of the interval the identity f prime of x is equal to f of x is true. So he is saying that the inverse process of differentiation is called integration. When we know the rate of the change of the function and we want to know the original function, we will take the integral of the functions. Find the antiderivative of the function. So we have a function f of x is equal to x square and we want to find the antiderivative integral of the function. From the definition of the antiderivative, it follows that the function f of x x cube divided by 3 has the antiderivative of f of x is equal to x square, since f prime of x, f of x is equal to this one. So we know that when we take the integral of x cube divided by 3, we will get x cube. So the antiderivative of x cube is x square is x cube divided by 3. Constant of integration. It is easy to see that if the given function f of x exists an antiderivative, then the antiderivative will not be the only one. In the example 1, we will take the following functions as antiderivative: f of x is equal to x cube divided by 3 plus 1, f of x is equal to x cube divided by 3 minus 7, x cube divided by 3 plus 3 plus c of the function f of x is equal to x square, since f prime of x is equal to f of x. It may be provided that the function of the form x cube divided by 3 plus c for any constant value of c exalt all antiderivatives of the function f of x is equal to x cube. This developed a consequence of the following theorem. So we know that x cube x square is the function, and when we take the derivative of x cube divided by 3, we will get x square. When we take the derivative of x cube divided by 3 plus 1, we will also get this one. When we take the derivative of x cube divided by 3 minus 7, we will also get x square. And when we will take x cube divided by 3 plus c, c is here constant. When we take the derivative of this one, we also get this one. So theorem number one, if f1x and f2x are two antiderivatives of the function f of x on the interval a b, then the difference between them is a constant quantity. Prove f1 prime x and f2 prime x are the derivatives of f1x and f2x. Then the virtue of the definition of the antiderivatives, we have f1 of x is equal to f of x, f1 prime x is equal to f of x. If we put the difference f1x and f2x and f1x minus f2x is equal to this one, if we put difference of f1x and f2x by f1x minus f2x is equal to 5x, then by virtue of definition of antiderivative for any value of x on the interval a b is equal to this one, f1 prime x minus f2 prime x is equal to f of x minus f of x. Derivative of f1 of x minus f2 of x is equal to derivative of this one is equal to 0. From x prime of x, it follows that this is equal to c is any constant quantity. It follows that if a given function f of x has antiderivative of x, then other antiderivative of f of x will be of the form f of x plus c for any constant value of c. The process of finding antiderivative is called antidifferentiation or inverse of the differentiation or integration. If the function f of x is an antiderivative of f of x, then the expression f of x plus c is of course the indefinite integral of the function f of x, and is denoted by the symbol integral of f of x is equal to f of x plus c if f prime of x is equal to f of x. The symbol this is called integral sign. So this is integral sign. This is integral sign, and the function f of x is called integrand. F of x is called integrand. The symbol d of x indicates that the antiderivative is performed with respect to the variable x. The arbitrary constant c is called the constant of integration, referring to the preceding discussion. We can write it integral of 2 of x d of x is equal to x square plus c, and d of dx plus c is equal to this one. The variables other than x can also be used in indefinite integrals. So derivative of 2t dt is equal to t square plus c dt, this one, and 2u du is equal to this one and this one. So you can also use the variable other than x. Standard integrals through standard differentiation formula. If f of x is any function of x, then in different situation the integral of f of x can be found directly in light of the indefinite integral definition from the chart of the integrals and the differentiation formula. The truth of the integrals can easily be checked by differentiating the right side of the integral, which always equals to the integrand. So these are the formulas about integral when you take the integral of x and d of x. So x and d of x, the integral of this one is equal to x n plus 1 divided by n plus 1 plus c, where n is not equal to 1. So when n is not equal to minus 1. So these are the formulas of integral. So integral of 1 divided by x dx, the integral of this one is 1 over natural log of x absolute plus c. So integral of cos of kx is equal to sine of kx divided by k. Sine of kx divided by k. And the sine of kx is equal to minus cos of kx divided by k. And the integral of cos square x is equal to tan of x plus c. And sine square x is equal to minus cot x plus c, and tan x is equal to minus natural log of cos of x plus c. So these are the formulas. So when you take the derivative of x n plus 1 is equal to xn. So when you take the derivative of this one, you will get this one. You will take the derivative of this one, you will get this one. When you take the derivative of this one, you will get this one. When you take the derivative of this one, you will get this one. When you take derivative of this one, you will get this one. When you take derivative of this one, you will get this one. When you take derivative of this one, you will take this one. Now next are formulas. So cot of x is equal to natural log of sine plus c, and e power mx is equal to e power mx divided by m. Ax is equal to ax natural log of a. This is equal to this one, and this is equal to this one, and this is equal to this one, this is equal to this one, this is equal to this one, and this is equal to this one, this is equal to this one. When you take the derivative of this one, you will get this one. When you take the derivative of this one, you will get this one. When you take derivative of this one, you will get this one. When you take derivative of this one, you will get this one. Similarly, now we will do some examples. So use the chart of the integral formula to evaluate the following integral. So first of the question, we have integral of x 1 divided by 3 d of x. So this will become the integral of this one is x 1 divided by 3 plus 1 divided by 1 divided by 3 plus 1. So this will become x 3 1 plus 3 divided by 1 plus 3 divided by 3. So this will become x 4 divided by 3, and into this will become 3 divided by 4. So 3x 4 divided by 3 divided by 4. So plus c. So this is our integral. Now we will solve next question. So we have the question integral of 1 divided by x cube d of x. So this will become x minus 3 divided dx. So this will become the integral of this one is equal to x minus 3 plus 1 minus 3 plus 1. So this will become minus 2 divided by minus 2 plus plus c. So when you take the derivative of this one, you will get this one. So this is also equal to 1 divided by minus 2x square plus c. You can also write it as this, like this one. So next question. So rules of the integration, recognition of the rules of the integration. D divided by df, f of x is equal to d divided by dx. F of x is equal to f of x plus c, where c is the constant of integration. So this is the proof of this one. So next we will see. So these are the R proofs. If all integral exists, then this is equal to this one, this is equal to this one. So when a constant is multiplying with a function and you take the integral of this one, you put the constant outside. This is also the formula. When there are two functions, you take derivative of this one and derivative of this one, and then add these two. So these are the formulas. Constant rule. So when you take the derivative of constant, so when you take the derivative of constant, this is equal to x plus c, and when this is k dot dx, so this will become k x plus c. And constant multiple rule, so this is equal to this one, and this is equal to this one, and this is equal to this one, power rule, and this is equal to this one. Next, evaluate the following integrals. So we have first integral 10 plus a dx. So take integral of 10 dx plus integral of a dx. So 10 is constant dx, and plus a is also constant dx. The integral of constant dx is this is equal to x, and this is also is equal to x, and this is constant of integral c. So next question is similar to this one, and this question is similar to this one. Standard definition of formula. Let f of so these are the proofs of all the formulas. So this is the proof of formula. Integration by substitution. You can integrate a function by substitution as well. So method of integration by substitution. In previous section, we saw how to integrate a few simple functions. More complicated functions can sometimes be integrated by substitution. The technique depends on the idea of the differential. If u is equal to f of x, then the differential of u with respect to du is denoted by du is equal to du f prime of x is equal to dx. So when u is equal to f of x, du divided by dx is equal to f prime of x, and du is equal to f prime of x into dx. Differentials have many useful interpretation which are studied in more advanced courses. We shall only use them as a convenient notation device when finding an antiderivative such as this one. So this is the integral. So the function this is reminiscent of the chain rule, and so we shall try to use differentials and the chain rule in reverse to find the antiderivative of u is equal to this one, then du is equal to this one. Now substitute this to this and we will get this one. Now we will solve this question. We have the question. We have to find the integral of x square under root x cube plus 1 d of x. So let u is equal to x cube plus 1. So du divided by dx is equal to d divided by dx x cube plus 1. This will become du divided by dx is equal to 3x square plus 0. So this will become du divided by dx is equal to 3x square, and this will become du is equal to 3x square dot dx. So this is our original question. This is our original question. So we can write it as x square is equal to du divided by 3. Sorry. So we can also write it as du is equal to 3x square dx du divided by 3 is equal to x square dx. So the original question is derivative of x square under root x cube plus 1 dx. You can write it as x cube plus 1 dot x square dx. Now this x square dx is equal to this one du divided by 3, and this is equal to u. So this will become u under root dot du divided by 3. So this 3 is constant. We can write it as 1 divided by 3, and this will become under root u du. We can write it as 1 divided by 3, 1 divided by 2. So x is not equal to minus 1. So we can use the formula 1 divided by 3 dot x 1 divided by 2 plus 1, 1 divided by 2 plus 1 plus c. So this will become 1 divided by 3x. This will become 3 divided by 2, and this will become 3 divided by 2. So this will become 3 into x cube divided by 2 into 2 divided by 3. So this will become 1 divided by 9 to x 3 divided by 2. Now sorry, u divided by 2. Sorry. So this is u, this is u, this is also u, this is also u. Sorry. So this is u, this is also u, this is also u, this is also u. So this is also u. So put the value of u. U is equal to x cube plus 1, x cube plus 1. So this will become 1 by 9 dot 2 x cube plus 1, x cube plus 1, 3 divided by 2, which is equal to 2 divided by 9, x cube plus 1, 3 divided by 2. So this is our answer. So it is complicated derivative, and we solve it with the help of substitution. So these are the general indefinite integral formulas. If u is a function of x, when u is equal to f of x and du is equal to f prime x dx, then f of x is equal to n f prime of x dx, then u of x n du. So this is equal to u x n plus 1 divided by n plus 1 plus c. So this is the formula. F prime of x divided by f of x is equal to du. U f of x is equal to natural log of x plus c. So this is equal to e of f of x, f prime of x is equal to e power u du, and these are the all formulas. If k is the real number, k is not equal to 0, then e power x is equal to e power x, and kx is equal to kx divided by k, and ax is equal to this one. So now we will solve all these questions. So this is the question. F of x is equal to integral of x cube minus 5x plus 7 whole power 4 dot 3x square minus 5 dx. Now we will let u is equal to x cube minus 5x plus 7. So du divided by dx is equal to 3x square minus 5. So this will become du is equal to 3x square minus 5 into dx. So this will become du, and this will become u 4 dot d of u. So this will become u 4 power 1, 4 plus 1, 5 divided by 5 plus c. So put the value of u. So this will become x cube minus 5x plus 7, 5 divided by 5 plus c. So this is our answer. So similarly, this question So this is the next over question. D of x 9x plus 7. So let u is equal to 9x plus 7. So du divided by dx is equal to 9. So this will become du divided by 9 is equal to d of x. So putting values, so this will become u, and this dx is equal to du divided by 9. So 9 is constant, so 1 over 9 1 over u du. So this will become, so this will become 1 over 9 natural log of u. So this is our answer plus C. So next question we have e power 3x plus 2 dot d of x. Now let u is equal to 3x plus 2. So d of u divided by dx is equal to 3. So this will become du divided by 3 is equal to dx. So this will become e power u, and dx is equal to du divided by 3. So this will become 1 divided by 3 and e power u du. So derivative of e power u is e power u. So e power u plus c. Put the value of u, which is equal to 3x plus 2 plus c. So in this way we can solve the questions of integral by the method of substitution. So we have solved all the question. So this is our next question. If the area A of the healing wound changes at the rate of approximately dA divided by t, dt is equal to minus 4 t cube, where t ranges from 1 to 10, and t is the time in days, and the wound area A is equal to 2 square centimeters on t is equal to 1. What will be the area of the wound be in the 10 days? So the rate at which the wound area changes, so the rate of change is given. So the wound area is obtained by integrating equation with respect to t. So this will become this one. So the integral of this one is equal to a. So a of t is equal to, we take the integral of this one, so we get this one. Now we put t is equal to 1. For t is equal to 1 and the area is 2, so we find the value of c. So constant is 0, so put c is equal to 0. So a of t is equal to 2 divided by t square. So when you put t is equal to 10, you find the area when t is equal to 10. Now next question. So the next is exercise. So exercise is easy. We solve the questions one by one. So first of all, we have to solve question number 1. So first question is evaluate the following. So the first part is x cube dot the derivative of x cube dx. So this will become x. So we apply the formula of this one. So we have the formula x of n d of x is equal to x n plus 1 and n plus 1 plus c, where n is not equal to minus 1. So here we see that the n is not equal to minus 1. So the integral of this one becomes x4 divided by 4 plus c. Similarly, we solve the next part. So the next part of this question is integral of a plus 15 and dx. So integral, apply integral on this one and this one. So a dx plus 15 dx. So a is constant and 15 is also constant. A is constant. Dx plus 15 is also constant. Dx. So I can write it as, for your convenience, I can write it as a x power 0 dx plus 15 x power 0 dx. So we apply the same formula in of previous question. So this will become a x 0 plus 1 and 0 plus 1. So this will become x 0 plus 1 and 0 plus 1 plus c. So this will become ax divided by 1 plus 15x divided by 1. So this will become ax plus 15x and constant of derivative c. So we will solve next question. C part of this one, 1 divided by 5x dx, derivative of this one. So 1 over 5 is constant. We can write it at outside d of x. So this will become, so we know that the derivative of 1 over x dx is equal to natural log of x. So this will become 1 over 5 natural log of x plus constant of derivative. So next question. So the next question is 3x square plus 4x minus 5. So derivative of 3x square plus 4x minus 5 dx. So we apply derivative on this one, and this one. So I can write direct answer of this one. So will become x cube divided by 3 plus 4x square divided by 2 minus 5x. So this is our answer, x cube plus 4 2 x square minus 5x. So this is our final answer. Part D of the question is part D is 1 plus 3t into t cube dt. So this will become multiplying t with both of these. So this will become t cube plus 3t power 4 and dt. Apply integral on both of these. T cube dt plus 3 is constant. I can write it at outside. So this will become t4 divided by 4 plus 3 t5 divided by 5. So this is our answer plus c, constant of integral. So question number 5, e of 5x, e of 5x. So integral of e power 5x dx. So this will become e power 5x divided by 5 plus c. The next question is H question, 5 1 plus x square and this one and d of x. So we can solve it as let u is equal to, sorry, so this is the question, integral of H question, integral of 5 1 plus x square d of x. So the integral of this one is equal to integral of this one is equal to 5 1 plus x square divided by dx. So what is the integral of this one? So when you take the derivative of tan inverse of x, when you take the derivative of tan inverse of x, you will get 1 plus x square. So this will become 5 1 plus x square dx is equal to, so this will become tan inverse 5 tan inverse of tan inverse of x plus c. So this is the integral of this one. Now we will solve next question. So next question is I question t cube integral of t cube under root t d of t. So we know that t cube t power 1 over 2, when the numbers are multiplying and the power, we will add the power, so this will become 3t. So this will become 2 6 plus 1 t dt, and this will become t power 7 divided by 2. Now this will become, so this will become t power 7 divided by 2 plus 1, 7 divided by 2 plus 1. So this will become t, and 9 divided by 2 and 9 divided by 2. So this is equal to 2t 9 divided by 2 divided by 9. So this is our answer, plus c, constant of integration. So we have next questions. So the next questions are question number 2, part 1. So we have to find these questions with the method of substitution. So the integral of 3x plus 4 power 8 divided by dx. So here we let u is equal to ut, anything you can let. U is equal to 3x plus 4, and du divided by dx is equal to 3, and du divided by 3 is equal to d of x. At the place of d of x, you can write du divided by 3, and at this one you can write u. So this will become u power 8 du divided by 3. So this 3 is constant, you can write it as this one. So apply formula, 1 divided by 3 u power 9 divided by 9. So this will become 1 divided by 27 u power 9 plus c. Now put the value of u. What is the value of u? U value is 3x plus 4. 3x plus 4. So this will become 1 divided by 27 3x plus 4 whole power 9 plus c. So this is our answer. So next part. Question number 2, second part, part B. So this is equal to integral of 3. This question is 3x square x cube minus 4 d of x. I can write it as like this one, x cube minus 4 3x square dx. Now let u is equal to x cube minus 4. So du divided by dx will become 3x square minus 0. So this will become du is equal to 3x square dot dx. At the place of 3x square dx, I can write it du, and here I can write u. So this will become u dot du. So the integral of this one is u power 2 plus c. Now put the value of u, which is equal to x cube minus 4. So this will become x cube minus 4 whole power 2 divided by 2 plus c. So this is our answer. Part C of this question number 2. So part C of question number 2, integral of 3x square plus 7 and x square x cube plus 7x whole power 8. So here substitute the number which is bigger one. So this is bigger number. Okay, so I can write it as x cube plus 7 x whole power 8. So 3x square plus 7 dx. I can let this is equal to u. Let u is equal to x cube plus 7x. So this will become du divided by dx is equal to 3x square plus 7. So this will become du is equal to 3x square plus 7 into dx. So at this one I can write du, and here I can write u. So this will become u power 8 dot du. So this will become u power 9 divided by 9 plus c. So put the value of u. U is equal to x cube plus 7x. X cube plus 7x divided by 9 whole power 9 plus c. So this is our final answer. Question number 2, part D. So part D is, this is our part D. Question 2, integral of 3x square minus 7 and x cube minus 7x 4 dot dx. Now let the number which is bigger one. Now let u is equal to x cube minus 7x. So du divided by dx is equal to 3x square minus 7. So this will become du is equal to 3x square minus 7 into dx. So at the place of 3x minus 7 into dx, I can write du, and here I can write u. So this will become u power 4 du, and this will become u power minus 4 du. So this will become u power minus 3 divided by minus 3 plus c, and put the value of u, which is equal to 3x square x cube minus 7x. X cube minus 7x. So this will become x cube minus 7x whole power minus 3 divided by minus 3 plus 6. So this is our answer. So next question, E part, integral of 6 of t under root 3t square minus 7 d of t. Now let the bigger number, let u is equal to 3t square minus 7. So this will become du divided by dt. Here you cannot write du divided by dx, because here the variable is t. Du divided by dt is equal to 6t minus 0. So this will become du is equal to 6t dot dt. So here dt into 6t dot dt, I can write du, and here I can write u. So this will become du 1 divided by under root t. So this will become, sorry, u, here I can write u. So this will become u power minus 1 by 2 du. So this will become u minus 1 by 2 plus 1 minus 1 by 2 plus 1. So plus c, constant of integration. So this will become u power, so this will become 1 by 2, and this will become also 1 by 2 plus c. So this will become 2 here, and u 1 by 2. Put the value of u, which is 3t square plus minus 7. 3t square minus 7 to 3t square 3t square minus 1 whole power 1 by 2. This will become 2 under root 3t square minus 1. Now next question. Now the f part of question number 2 is equal to integral of r power 1 by 3 plus 4 under the root divided by r power 2 divided by 3 dr. So this will become, now let the number which is bigger one, so let u is equal to r 1 power 3 plus 4. Now take the derivative with respect to r, du divided by dr is equal to 1 divided by 3 r 1 by 3 minus 1 plus 0. So this will become du divided by dr is equal to 1 divided by 3 r 1 minus 3 divided by 3. So this will become du divided by dr is equal to r power minus 2 divided by 3, and I can write it as du is equal to r power minus 2 divided by 3 dr, which implies that du is equal to 1 divided by r2 power 3 dr. At this place, dr divided by r power 2 divided by 3, I can write du. I can write du, and here I can write u. So this will become integral of u, and here I can write it as du. So this will become u power 1 by 2 plus 1 divided by 1 by 2 plus 1 plus constant of integral. So this will become u 3 power 2 divided by 3 divided by 2 plus c. So this will become 2u 3 divided by 2 divided by 3 plus c. So put the value of u, which is equal to r power 1 by 3 plus u. So r power 1 by 3 plus u, r power 1 by 3 plus 4 whole power 3 divided by 2 plus c divided by 3. So this is our answer. So now we will discuss next question. So the next question is g part, and g part is equal to x plus 3x square under the root x dot d of x. Now we will solve this one. I can write it as I can write this question, g part of the question is, I can write it as x divided by under root 3 plus, x plus 3x square divided by under root x. Now I can write it as x divided by under root x plus 3x square divided by under root x. So I can write it as under root x divided by under root x dx plus under root 3x square under root x dot dx. So this will become x power 1, and this will become x power 1 by 2, and when it goes up, this will become minus 1 by 2 dx, and here 3 is constant. So we can write it as this x power 1 by 2, when it goes upward, x power minus 1 by 2 dx. So this will become x power minus 1 by 2 and plus 1. So this will be x power 1 by 2, and this will become x. So this will become 4 minus 1 divided by 2 d of x. So which implies that this is equal to, so this will become 3 divided by 2, and this 3 divided by 2 plus, so this will become 3 divided by 2 and x 3 divided by 2 plus 1, x 3 divided by 2 plus 1 plus c. So this will become x 2 5 divided by 2 and 5 2 here and 5 here. This is our final answer. Now the next part is now the next part of the question is last part, h part is equal to x plus 1 and x square plus 2x plus 2 whole square dot d of x. So we will solve this one. Now let the bigger number let u is equal to x square plus 2 of x plus 2. So this will become du divided by dx is equal to 2x plus 2, and I can write it as du divided by dx is equal to 2 common x plus 1. I can write it as du divided by 2 is equal to x plus 1 into dx. So at the place of x plus 1 into d of x, I can write du, and here I can write u. So this will become u, sorry, so this will become 1 divided by u square and d u, and this is equal to u power minus 2 du, and this will become the integral of minus 1 divided by minus 1, and put the value of u which is equal to minus and u value x square plus 2 of x plus 2 minus 1. I can write it as minus 1 into x square plus 2 of x plus 2. This is our final answer. Now we will discuss next questions. So find the equation. Find the equation of the partial curve that has a slope of this one at a point this one. So the slope is equal to question number 4. We left question number 3. First we discuss question number 3. So question number 3, evaluate the following indefinite integral by the methods of substitution. So we have to solve all these questions with the help of substitution. So first question is question number 3, part A. So part A, 6 e power 6t dot dt. Now let u is equal to 6t. So du divided by dt is equal to 6. So this will become du is equal to 6 dt. At the place of 6 into dt, I can write du, and here I can write u. So this will become e power u du, and this will become eu plus c. So put the value of u, which is equal to 60 e power 60 plus c. So this is our final answer. So next question is part B of the question is x dot e 5x square plus 1 and d of x. Let u is equal to 5x square plus 1. So du divided by dx is equal to 10x plus 0. So this will become du divided by 10 is equal to dx dot x. I can write it as x dot dx. So at the place of x dx, I can write du divided by 10. Here I can write u. So this will become e power u. At the place of x dx, I can write du divided by 10. So this will become 1 over 10 integral of eu du. So this will become 1 over 10 e power e power u plus c. So put the value of u 1 over 10 e power 5x square plus 1 plus c. So this is our final answer. So next question is part C of question number 3. So this is equal to integral of x square minus 2. So x cube minus 6x plus 4 d of x. So this is e power this one. Okay, I can write it as integral of x square minus 2 and e power here e power is x cube minus 6x plus 4 and dx. Now let u is equal to x cube minus 6x plus 4. So du divided by dx is equal to 3x square minus 6. So take 3 as a common. Du divided by dx is equal to 3 common, x square minus 2. So this will become du divided by 3 is equal to x square minus 2 into dx. So at the place of x square minus 2 dx, x square minus 2 into dx, I can write du divided by 3 and here I can write u. So this will become integral of 1 divided by 3 into e power u du. So this will become 1 divided by 3 e power u plus c. So put the value of u, which is equal to x cube minus 6x plus 4. 1 divided by 3 e power x cube minus 6x plus 4 plus c. So this is our final answer. Now we will discuss part D of the question 3. Part D of the question 3, integral of 8 power 7 minus 3x square and minus 6x dx. So this will become now let u is equal to 7 minus 3x square. So du divided by dx is equal to 0 minus 6x. So du divided by dx is equal to minus 6x, and this will become du is equal to minus 6x dot dx. So at the place of minus 6x dx I can write du and here I can write u. So this will become integral of 8 power u dot du. So this will become we know that a power x dx is equal to a power x natural log of a. So this is the integral of a power x. So the integral of this one will become 8 power u divided by natural log of 8 plus c. So put the value of u, which is equal to 8 power 7 minus 3x square divided by natural log of 8 plus c. So this is our final answer. So this is the D part of question 3. Now we will discuss question number 4. Question number 4. Find the equation of a particular curve that has a slope of this one at a point 1 and 0. So here we have a question. Slope is equal to 4x cube plus 6x square. We know that slope is equal to d y divided by dx is equal to 4x cube plus 6x square. So we can write it as dy is equal to 4x cube plus 6x square dot dx. Now taking integral on both sides, so here we take integral and here we take integral. Let the original equation is equal to y. Let the original equation is equal to y. So this will become y is equal to, when we take the integral of this one, so this will become 4x4 divided by 4 plus 6x cube divided by 3 plus c plus c. So this will become y is equal to this is cancelled with this one, so x cube plus this one, this 2x cube plus 3. Now put the values, this is y and this is x. So put y is equal to, no sorry, this is x and this is y. So x is equal to 1, y is equal to 0. 0 is equal to 1, 4 plus 2, 1 cube plus c. So this will become 0, 1 plus 2 plus c. So this will become 3 minus 3 is equal to c. So put the value of c is equal to minus 3. So this will become, this is our equation. Put the value of c, which implies that y is equal to x4 plus 2x cube minus 3. So this is our original equation, which has the slope of this one. Now we will discuss next question, question number 5. Question 5. Now the question 6, sorry, question 6. If the rate of excretion of a biochemical compound is given by f prime of t is equal to this one, find as expression f of t, the total amount exerted by the time t in minutes. F of 0 units are expected at t is equal to 0. How many units are expected in 10 minutes? For if f of 0 is equal to 0 units are expected at t is equal to 0, how many units are expected in 10 minutes? So we write the equation f prime of t is equal to 0.01 e power minus 0.01 into t. So this will become taking integral on both sides, f prime of t dt is equal to 0.01 e power minus 0.01 t d of t. We can solve it with the help of substitution as well, or you can solve it as direct. So this will become f of t is equal to e power minus 0.01 into t, and this will become minus 0.01 into 0.01, this one, plus c. So this will become, this is cancelled with this one. So f of t is equal to minus e power minus 0.0 t plus c. So this is our original equation. Now he is saying that if the rate of the excretion of the biochemical compound is given, find an expression of f of t. So this is the expression of f of t in minutes. So if f of 0 is equal to 0 units, f of 0 is equal to 0 units are expressed at t is equal to 0. So this is f of t is equal to 0 at t is equal to 0. So f of 0 is equal to minus t minus 0.001 into 0 plus c. So this will become f of 0 is equal to minus e power 0 plus c. So this will become f of 0 is equal to anything power 0 is equal to 1. So c is equal to plus 1. C is equal to plus 1. So put the value of this in the equation. f of t is equal to minus e power minus 0.01 into t, and value of c is equal to 1 plus 1. So f is equal to 10. So f is equal to 10. So this will become minus e minus 0.01 into 10 plus 1. So this is our equation. So we can write it as f of 10 is equal to, when we multiply this will become e 1 over e, and this will become 0.1 plus 1. So this is our final answer. So next question is question number 7. For an average person, the rate of the change of the weight w in pounds with respect to height in inches is approximately is equal to dw divided by h is equal to this one. Find w of h if the weight is equal to this one in response of the height is equal to this one. Find the weight w of a person who is 5 feet 10 inches tall. So we have the equation f of dw divided by question number 7, dw divided by d of h is equal to 0.0015 h square. Taking this is equal to dw is equal to 0.0015 h square d of h. Taking integral on both sides, integral of dw is equal to integral of 0.0015 h square d of h. So this will become weight is equal to 0.0015 integral of h square d of h. So this will become w is equal to 0.0015 h cube divided by 3 plus c. So he has given that when w is equal to 108, h is equal to 60, and w is equal to 108 is equal to 0.0015, then h is equal to 60 divided by 3 plus c. So this will become 1s are, and this is equal to 2 and 0. So this will become 108 is equal to 0.0015 into 20 plus c. So we can solve this one. Zero point zero zero 0.0015 into 20. So this will become 108 is equal to 0.03 plus c. So 108 minus 0.03. So this will become c is equal to 107.97. So we have the equation. W is equal to 0.0015 h cube divided by 3 plus 0107.97. Now he is asking about sorry now he is asking about find the weight w is equal to unknown when the person is 5 feet. Now first of all, we convert the feet into inches, because we convert the feet into inches. So 5 feet is equal to 1 feet is equal to 12 inches. So 5 feet is equal to 60 inches. So 60 inches when w is equal to Here weight is equal to unknown, weight is equal to unknown when h is equal to h is equal to uh, 5 feet. Now we know that this h is not in feet, this is in inches. So h is equal to 5 into 12 inches. So this will become h is equal to 5 into 12 inches. This will become 60 inches. So put h is equal to 60 here. So w is equal to 0.0015 into 60 cube. 60 here we have done the mistake in. Okay, now here we not take the cube of h. So we solve it again. We have not take the cube of this one. So this h is equal to 60 cube divided by 3. So this will become 60 into 60 into 60, 60 into 60 into 60. So this will become this one multiply by 0.0015 this and divided by 3. So this will become 108. So 108 is equal to, when we solve all this one, this will become 108. This will become 108 plus c. So 108 minus 108 is equal to c. So c is equal to 0. So the equation will become w is equal to 0.0015 h cube divided by 3 plus 0. So this is our equation. When he is asking that when find the weight when h is equal to how much? H is equal to 5 feet. Now he has given that h is the height in inches. So we have to convert this in inches. So this is equal to h is equal to 5 into 12 inches. In 1 feet we know that there is 12 inches. So h is equal to 60 inches. So we have to find this one. So this will become w is equal to 0.0015 h cube divided by 3. When we solve this one, we will get w is equal to 108 pounds. So this is the question. Now we will discuss question number 8, last question of this exercise. Last question of this exercise is, so this is the question: the rate of the growth of the population n of t of newly incorporated city t years after incorporation is estimated to be d, and divided by d t is equal to this one. If the population was this one at the time incorporate, find the population 9 years later. So we have the question. Dn is equal to dn divided by dt is equal to 400. Question number 8. 400 plus 600 under root t, and when t is greater than or equal to 0 and less than or equal to 9. So we have to find dn is equal to 400 plus 600 under root t into d of t. Taking integral on both sides, here we take integral and here we take also integral. So this will become n of t is equal to 400 d of t plus 600 under root t d of t. So this will become n of t is equal to 400 d of t plus 600 under root t d of t. So this will become n of t is equal to 400 t plus 600 t 3 divided by 2, and this 2 here and 3 here plus c. So this will become 1s are, and this is 3 0 0, and when we divide this one, this will become 400 t plus 900 t 3 divided by 2 plus c. So this will become n of t. He said that when population is 5000, when t is equal to 0, when t is equal to 0, population is 5000. So when t is equal to 0, n of t is equal to 5000. So this will become 5000 is equal to 400 into 0 plus 900 0 3 divided by 2 plus c. So this will become 0 plus, this will become also 0 plus c. So c is equal to 5000. So the equation is n of t is equal to 400 into, this will become t plus 900 t 3 divided by 2 plus c value is this one. So after 9 years, n of 9 is equal to 400 into 9 plus 900 into 9 3 divided by 2, so plus 5000. Now when you solve this one, you will get answer, and the answer of this one is equal to when you solve this one, you will get the answer n of 9 is equal to 19400. So this is our final answer. So in the next video, we will discuss next exercise.